And okay, over the next 20 minutes or so, we'll be talking about sashimi quality and some of the challenges we hear from our customers. What is the Deepchill solution for that, and how is the process of integrating Deepchill to shrimp operations? Deepchill impact on the product quality, and in the end, we are going to talk about what's the impact on the bottom line of your business. So I've been with the Deepchill team for over 5 years now, and over this period, I had a chance to meet with many shrimp producers and prawn producers, and there are some common challenges that I hear from them in conversations. One of the key challenges, as with any other seafood, is that shrimp is very delicate, very sensitive product, and it's very quick to spoil, especially if it's not dealt and if it's not handled really well in terms of temperature control, in terms of getting enough cooling for the product as soon as it's out of water. And any damages that happen during this time, it's irreversible. So you want to make sure from the beginning that this doesn't happen. Shrimp doesn't start spoiling that quick. The other challenge is the ice consumption and how high it is and how labor intensive it is. This is especially more significant when we talk with people who deal with warm water shrimps, because the product is much warmer when it comes out of water, and just chilling it down, it takes a lot of time, takes a lot of ice, and takes many people to handle that ice. So that's another challenge. And non-uniformity of quality. What we mean here by that is that, as I mentioned, the ice handling process, it's a very manual process. And many people are involved during that. So imagine if we are taking shrimps into insulated tubs, and you're trying to put some ice in it and mix it and layer it. Somebody likes to put less ice. Somebody is going to put more ice there. Somebody put a little bigger layers in the top. So all of that will add to non-uniformity of the temperature in a single tub. And what that essentially means, the quality in the end is not going to be very consistent. And as a processor, you want to make sure that quality that you have, it's always high and it's always there. You can promise the same quality in this batch and next batch that you do next week and the ones afterwards. So another thing is another issue is the temperature control. So during the process, whether we are dealing with wild shrimp harvesting from the sea, or you're harvesting from the farm, the temperature control coming from the farm, getting it to the processing, and throughout the processing, it's very difficult to keep it as low as possible and don't let it fluctuate. So every time we have shrimp out of, let's say, ice or the cooling medium, every time it's during transportation, every time we are dealing with like manually handling it, peeling, deheading, and whatever process that you're doing, the temperature rises up very quickly. So every time that temperature rise happens and this fluctuation goes on, we are degrading the product quality. The other issue is the mechanical damages that happen during, like say, ice handling, during transportation, during storage times. And that's even more significant for producers who deal with head-on shrimps, because you want to make sure that product is looking as good as it could. The antennas are all there, the legs are not broken, the shell is untouched. You don't want it to get damaged, which is pretty common if you deal with, like, imagine like 100 pounds of ice you're dropping on this delicate shrimps. Of course it's going to get damaged. Maintaining hygiene. Because this whole process is very manual again, there are lots of opportunities or lots of risks of contamination during this period. Shoveling ice, storage of ice, storage of product in ice. So all of that is very much open to contamination. And we don't want that, obviously, in any food processing environment. So we talked about the challenges. Let's just quickly look at the cold chain and what the Subzero cold chain can do for producers. Here is a relative rate of spoilage of products, of seafood products. As you can see, it directly correlates with the storage temperature. So the higher this temperature, the faster the product is going to spoil. And if you see here, if we store the product at 4 degrees Celsius, comparing to 0 Celsius, the product is going to spoil at a double rate. What would that mean in your operation? So say here's the conventional storage temperature. Somewhere from 0 to 4 degrees is pretty common. 0 is pretty harder to achieve, so it's usually like 1 to 2 degrees Celsius, or like 33, 34 Fahrenheit to 39 Fahrenheit is pretty common. What we like to see is this deep chilling zone, where the product is below 0 degrees or below 32 Fahrenheit, but still above the freezing point. We don't want to freeze the product, but we want to keep it as cold as possible. Why would that matter? Because the studies show dropping this temperature from 1.5 Celsius to -1.5 or 29 Fahrenheit, it will drop or it will cut the bacterial growth rate by half, meaning that the product, the shrimp, is spoiling at half the rate, half the speed. In other words, if we are able to maintain this temperature throughout the cold chain, we can extend the shelf life of the product. And that's more important for obviously for fresh products when we deal with like harvested from wild shrimps. It also matters for the people who deal with processing side. So that's about the deep chilling zone, which is gonna give you the top best possible quality or outcome of the process. Now, I mentioned Deepchill a couple of times. So what is Deepchill? Deepchill is this versatile cooling and preservation solution. What is essentially made of is billions and billions of microscopic crystals that are suspended in a brine solution. And the beauty of it is that it's a designer solution. We can control pretty much everything, including how much or what percentage of crystals are suspended in water. So what you see on the left side is a Deepchill with 10 to 40% crystal concentration, which means it makes it pretty liquid. It looks and flows just like water. So it's very easy to apply. It's pumpable. And because it has these tiny microscopic crystals, it doesn't separate as easy. So if you look at, for example, something that's called fake slurry, or they mix crushed ice with water and mix it, and they call it a slurry, it's really made of ice pieces or ice chunks and water. It separates as quick as possible. Like just like when you put some ice in your glass of water, immediately ice flows to the top. When you use that in a container of shrimps, the shrimps on top are going to be touching ice. The shrimp at the bottom is not getting that cooling. So you will have a different temperature throughout this container. So that's about the separation part. The higher concentrations, you will end up with a much thicker paste-like or ice cream-like deep chill. And in the right side, what you see is a DC 100, which means the 100% crystals. If I want to show you in a little video here, this is how deep chill slurry flows. The second one you see here is the ice cream-like or paste-like form of deep chill, which has a much higher concentration. And the last one is just crystals. So the beauty is that depending on your process, depending on your product and your operation, we can design the right solution for you that's going to give the right amount of cooling, that's going to give you the right amount of automation, all you need for the operation. And just in the end, the end goal is to focusing on the results that you want to achieve from your process. Here is comparing cooling factor of deep chill versus chilled brine. So a deep chill with 25%, it can have a 5 times higher cooling factor. It's in this diagram, you see heat transfer coefficient, but it directly correlates with how much cooling power, in a sense, the solution will have for you. That is exactly why it's capable of cooling the product much, much faster than any other solution, whether it's just ice, whether it's a combination of ice and water, just chilled water. Deep chill has the power to cool any product much, much faster. And so I'll pass it to Kyle. He is going to talk about how this deep chill, how this magic can be applied to shrimp and what the impact it's going to have.
Thank you for that, Mina. You know, I find that I always get the fun slides to present, and this one is a really cool video. So I have customers ask me all the time how deep chill integrates into their shrimp operation. And here we can see an aquarium style view of shrimp going into deep chill, moving around, and we just drain the brine. So the brine drains and the ice remains. And we see the shrimp completely suspended within deep chill ice crystals. You can see the crystals starting to dry out there. Beautiful. So just some compare and contrast points. With deep chill, you get rapid and uniform cooling. And that's one of the issues with cooling shrimp, in the sense that you're layering shrimp and ice, and the ice doesn't make full contact with the shrimp. And it's the phase change where all of the energy comes from. So when there's not great contact, there's not great heat loss. And also the shrimp are suspended in deep chill, so there's no damage to the shrimp during transport. This minimizes discoloration and black spots and provides producers and processors with a long-lasting preservation tool. So again, just some compare and contrast points. We can see shrimp submerged in deep chill on the left and shrimp in flake ice on the right. And you'll notice with deep chill, the crystals are a fraction of the size of flake ice, and they're soft, round crystals. So it doesn't do any damage to the shrimp, and it completely flows and molds around the shape of the shrimp. There's no heat or air pockets, and at the end of the day, no damage is done to the shrimp. Whereas if you look on the right-hand side, these are sharp-edged pieces of ice that are shoveled, manually shoveled into the box. And this creates air and heat pockets inside the box. And if you've put thermistors in different shrimp inside your insulated container, you'll notice that they're different temperatures depending on where in the box they are. And at the end of the day, this causes shell and antennae damages. And if you do sell sashimi quality shrimp that are head on, including the antennae, this is an important point for the customer. But at the end of the day, our claim to fame is that we drop that temperature so darn quickly and to a low, very low temperature that it stops bacterial degradation. So on the left-hand side, you can see the standard method of putting 25 pounds of shrimp in with 44 pounds of flake ice. And over the course of 4 hours, it gets to about 1.5 degrees Celsius. Whereas with Deepchill, within 4 minutes, in some cases, we're able to bring it down to 0 degrees Celsius. So better cooling in less time. That's what we do. And here is just some of the research that was done. Here we can see the freshness limit at about 20 milligrams per 100 grams of TVPN. And the bottom line is showing shrimp stored in slurry ice or deep chill. And you can see the top line where shrimp are stored in the conventional method. And this matches what a number of our customers are saying, that they get somewhere between 7 and 8 days of usable shelf life when they store shrimp and flake. Whereas with deep chill, we can extend that by 100%. So to go from 8 days to 16 days in terms of shelf life. And in the T-bars on the right, we see the exact same thing. The freshness limit there is about 1.1. And we can see at day 8 with flake ice, that's the results you're getting. Whereas even by day 16, we're showing better results than by day 8. So where do we fit into your cold chain? So we are not here to completely reinvent the wheel. We are not here to completely change your operation. What we do is integrate with your current operation method and allow you to get better results. So in terms of harvest, we would suggest chill killing into a tote of deep chill. So we drop that temperature right away at the point of harvest to maximize the quality and shelf life. Secondly, in transport, even if they're not harvested into deep chill, they should be transported in deep chill or slurry ice so that we drop that temperature during transport so they arrive at the processor in the best condition. And then at reception, being stored in deep chill allows us to continue to respect the cold chain and maintain a sub-zero temperature. Then the sorting and maturation process. So we all know that if the shrimp aren't chilled very well right before cooking, those shells are going to stick to the meat and it causes a lot of problems in terms of production. So pre-chilling is definitely an area of concern. And from there, it either goes to the raw process line. And again, the raw process line is where you'll see an increase in temperature, especially if it's done by hand. And again, if it's a cook and chill application, which most of them are, the shrimp will need to go through the maturation process. So you'll need to drop the temperature significantly in either case. And then in the freezer, if you're chilling after cooking or after the raw process line, we can increase the throughput and increase the efficiency of the freezer, which is typically a sticking point with many customers because the amount you can freeze is many times a limiting factor in terms of production. But what are we doing if we're not delivering results? So we've been doing this for 40 years. We actually invented the first slurry ice system that was ever created right here in Canada. And we have a number of success stories from every part of the globe. This is a shrimp harvester and processor in Canada. And what they found when they installed the deep chill system on their boat was that they were able to stay out longer because we bought them additional days of shelf life. And when they returned, the shrimp was of a higher quality, and even shrimp that was caught 3 days previously looked like it was just caught that day. And here we see a quote from the gentleman that the quality of the shrimp is 2 days better in color, freshness, firmness, and taste. But this was um, the basis of our name today. So there is a customer, Sopak in New Caledonia, and their shrimp is called Tenchi no Ibi in Japan, which roughly translates to shrimp from heaven. So they create a very high-end shrimp product, and they use Deepchill in their operation because they know that it increases quality or maintains that high level of quality and allows them to deliver a very high-end sashimi quality product to the Japanese market. And this is a different application, but it's a shrimp farm in Saudi Arabia, and it's a very large shrimp farm, and it allowed them to triple their delivery of grade A shrimp to a higher demand market, and at the same time increase their freezer output by over 20%. And they saw significant savings on ice handling and manual labor. And that's actually one point that we skip over a lot. When you think of your operation, think about the small army of people whose sole existence on your payroll is to move ice, take care of the ice, and then shovel the ice. It's madness. So we replace all of those people with a hose that they press a button and Deepchill comes out. And this also mitigates any contamination risks. What we've found through talking with processors and harvesters is that it's not the ice that typically carries the concern with contamination. It's the shovel. Because as they're shoveling ice, they go from shoveling ice and then they put the shovel down over here on the ground, or the shovel drops and no one washes it. So there's many different areas of concern. Whereas Deepchill can help with HACCP compliance as it's a closed loop system. So there's no contaminants in that Deepchill liquid slurry ice when it comes out of the hose. And here's just some additional pictures of the operation. We can see 2 large storage systems, and we can see the shrimp in a tote. We can see a very large system again here at the bottom, producing hundreds of metric tons per day of Deepchill. And if you compare and contrast us with like a flake ice operation, we're going to take up less space and use less power. But again, there's a number of different operational advantages. First and foremost, perfect temperature control and continuous cold chain. And we were speaking about that before. So most refrigeration companies or most conventional methods deliver somewhere between 1 and 4 degrees Celsius. Our claim to fame is going in the other direction and actually holding it between -2 and -1 degrees Celsius. And again, this has significant impacts on quality and efficiency through automation, while at the same time extending the processing window without compromising quality. Lastly, what is our impact on the bottom line? Because if we're not doing anything for you, if we're not delivering real results that you can measure, then why the heck would you invest in a Deepchill system? Well, first and foremost, we help maintain production yield. So there's been a number of customers who have reported to us in their QC testing that Deepchill did increase yield as opposed to flake ice, which removed some yield. And this was due to those air pockets that form when flake ice makes contact with the shrimp. Also, there's considerable savings in terms of labor costs. And it is just so darn hard to find people to work in the plants right now that you're probably not going to eliminate those positions. You'll use them in different areas of the plant, but at the same time, we've replaced an army of people with a hose. And also, this has significant impacts on product degradation, and degradation isn't something that we talk about a whole heck of a lot, but shrimp is just so susceptible to temperature and to degrade over time once it's above 0 degrees Celsius due to the enzymes that are present in the shrimp. And also, as we were saying before, if you're a harvester, we can help you extend your trip if you're not at full capacity. And here are just two quick ROI examples. There were a number of different ones we could have put on this page, but if you're a processor doing 50,000 pounds a day or 22,000 kilograms of shrimp, and the wholesale value of those is approximately $5 a pound, we've heard from a number of different processors that they're losing up to 1% during the harvest season due to cold chain issues. And it all comes down to ice. It all comes down to flake ice and how horrible of a solution it is for shrimp and how we've just been using it for so long that it's the standard method. And if you're a harvester and you don't always get a hold full of shrimp because you're limited in terms of time, we can help with that. So if you can stay out longer, you don't need to steam out to the area as often and steam back as often, make your operation more efficient. And at the same time, we eliminate the need to be pigeonholed into using a specific producer or processor as they're the ones who have given you the ice. So you can realize a higher value for your catch as the shrimp will be of higher quality and you can go to the processor of your choice. So here's our contact information. We would love to continue this conversation with you. We have a number of different success stories, and we would like for you to be one of the success stories with us. And Mina, I'll leave it up to you in terms of the question and answer period.
Thank you so much, Kyle. That was pretty good. Okay, we leave the floor open for your questions. We have a few more minutes left. I know it's usually difficult when you want to ask the first question. So maybe I can start with the first question. And Mark, maybe you can talk about, this is a question that we usually get from the customers. They always ask about what type of water do you need and what is the salt consumption in your system and all that. So maybe you can have like a couple of minutes, you can touch on that. Where is Mark?
He's on mute.
Oh, okay.
Sorry, yeah. You think after COVID, I would figure out how Zoom calls work. Yeah, thanks, Mina. Thanks to everyone for joining. Yeah, sure. So the question around salt does come up a lot. You know, you might be able to make, say, a slurry ice where you're literally just crushing ice and putting it in fresh water and calling it a slurry ice. We have a process that is very different. I always call it the light bulb to a candle in terms of the technology. We actually manipulate. So I'm running engineering here, so I'll try and not make it too technical. But we basically play on the chemistry of a binary solution, a binary system that has a temperature depressant or depressing component in it. And just the same way when it snows, we're here in Canada. Some of you folks might not see snow, but when there is snow and it's on the road, we go and we throw salt out onto the roads to melt the snow, right? What's happening there is the salt is mixing with the water and lowering its freezing point. And there's some chemistry at play there. And so what we do, we have some technology that basically leans on that and can coerce ice crystals to form in a bulk solution. And the way that Mina touched on in the beginning, they form in a very specific shape, almost like a snowflake, but almost the opposite of a snowflake in that they're pearl shaped rather than jaggedy shape. And so anyway, so the salt is required for the system to work. But unlike a lot of our competitors, we actually have a whole bunch of ways to address salt if salt tolerance is a concern for you guys, or concern for your operation or your process or your product or anything like that. So we can either have something colder and more saline or more salty, or if salt is a big issue like in produce, and I think in shrimp, there's also concerns around salt. We have ways of producing a deep chill that is less salty. We can make it almost unnoticeable. So for broccoli icing, for example, there can be no salt at all. So we have techniques and applicational knowledge of how to actually give you the deep chill that you need.
Mhm.
There was something I wanted to also talk about. We spoke about it yesterday, but I thought it's something that I'd like to cheer about the Deepchill team is as a company, we pride ourselves on not just selling you equipment, but actually really understanding your process and customizing a solution that is fit just for you and the perfect glove for your hand. I was going to try and show off how old I am and show a screen. Why don't you answer another question there where I try to figure out how to show a screen and then I'll jump in.
Sure. So Alejandro is asking, what is the smallest equipment and capacity? So Mark, you want to?
Smallest equipment capacity, yeah. So that is a question that we have as well. There are a lot of small operations that are interested in using deep chill systems, not just in shrimp, but in boats and all sorts of things. The smallest system that we have, it's kind of difficult to describe what it is because there's a lot of factors that determine the output. So, for example, your environmental temperature, the temperature of your cooling water, of your feed water, all sorts of things like that. But the smallest system we have can make something like 6 tons a day of, we call it DC 100, so the equivalent of an ice plant, of a 6-ton plant. Probably the most cost-effective modules that we can make are 12 tons a day. But that's of pure ice. Now, when you customize the actual fluid that you need, so you don't need the DC 100, obviously, you might need a 30, you might need a 40, you might need a 25. All of that sort of stuff we will figure out when we design the process for you. That 12 tons might turn into 25 tons or 30 tons or 40 tons, depending on really how much you dilute it.
And one thing to note from somebody who's not an engineer, that those figures are within a 24-hour period. So if you're not, fishing for 24 hours and you're only really fishing for 8 hours, you take that number and multiply it by 1/3 to get the value that you would actually use. So to Mark's point, if we're making 6 metric tons of pure ice, that would be 2 metric tons of pure ice during your 8-hour period. And at a 33% fraction, that would be about 6 full totes full of slurry ice, just so you can imagine.
Okay, I found the screen I wanted to share. Now I got to find the share screen button. Oh, it says I can't share it. Okay, well, that's
Hold on.
Anyway, what it was a process flow diagram of a client that we had worked with that had a shrimp processing facility and had multiple manual operating steps. This was a client in India. They had deheading, they had weighing, washing, they had pre-grading storage, they had grading, they had post-grading storage, they had further processing, they had chemical treatment, all sorts of stuff like that. And being in India, it was always sort of like 30, 35 degrees there. And so when we first spoke to them, they said, oh, we just want deep chill for these certain processes. And we helped identify issues in their cold chain. And we said, it doesn't actually help. You have 4 places here where your product's going to go up to, say, 15 degrees. So we tailored that deep chill system to actually address each of those stages so that their cold chain could be upheld. Sorry, maybe we'll throw the picture up on our LinkedIn page.
Yeah. Okay, sorry about that. So we have one more question. I think we have time to get to. How do you regulate the ice concentration, and if it's possible, how it can vary the ice slurry production if initially my system is DC 60% and then I change it to, say, DC 30 or 30%?
Yeah, okay, so the ice, because we understand the chemistry of how it works, if you know what goes in and you know its final state, you can figure out the ice concentration. So I'm trying to simplify. We basically take measurements of certain things, temperature, salinity, and stuff like that, and then knowing how the equations work, we can calculate the ice concentration. Moving it up and down is relatively easy within our systems. We will just turn on and off certain equipment at different times. If you need a thicker slurry, we would generate more of the ice crystals. If you need a thinner slurry, we would just make the generators run less. So it's very flexible. Anything you kind of need, we can do. Just a caveat on that: it's not instant. You can't, press a button and in 5 seconds you can jump up and down. There is a lag to it, couple of hour lag. But a lot of the times our customers have seasonality issues. So they want to say in summer we actually need it to be, have more ice crystals in there than in winter, and so it's more of a seasonality change.
Adjustable. Yeah.
Yeah, it is adjustable. Yeah, but not instantaneously.
All right, everyone. Thank you so much. I think our time is up. We went a little over. So once again, thank you. Thanks, Kyle and Mark, and hope to hear from everyone soon.
Okay,
Bye, everybody.
Thanks everyone.
Thank you.